So this section's about GCFing, or common factors. It's kind of the first step in factoring. This whole unit's about factoring. I probably would say, and I know I'm probably thinking I've been saying this every unit, but I would say that the method of factoring and doing factoring is probably the most important tool you'll need for Math 20. Math 20, they're factoring all the time. So they have to factor to solve stuff. So you have to have this practice and this tool in your bag of tricks when you get up there to use all the time. Okay, so make sure that this unit, a lot of questions, a lot of focus, anything I say that you don't understand, or if I go too fast, make sure you let me know, especially the factoring, because the hard thing, I think the hardest thing for teachers, and you may not realize this, the hardest thing as a math teacher is that, like, for example, when I was just telling you guys those multiplication tables, that's a pattern I know in my head that I've done for a much longer time than you have. So, like, when I do 14 times 12, it's pretty automatic for me. Might take some of you a little bit longer. Some of you can't even really do it. Okay, and so what I'm saying is factoring is a pattern. I've been doing this pattern since I was your age, basically, so probably 10 years now, okay, 12 years. So this is automatic to me. So if I do something too quickly, you really need to say, I don't see that. I don't understand that, okay? So that's what I'm trying to say is that I've done it for so long, sometimes I go too fast because I just assume that you think it's as easy as I think it is, okay? So overview of the unit. In this unit, we're going to introduce the process of factoring. This includes factoring by removing a common factor, which is what we're doing today. Factoring a trinomial with inspection and decomp. That's going to be factoring to two binomials. So taking a trinomial and making it two binomials. And then these techniques are illustrated concretely, pictorially, and symbolically. We express them as a polynomial and as a product of its factors. So that's just kind of an overview. Whoops. Okay. So expanding and factoring. So in the previous unit, we were concerned with multiplying polynomials expressions. In particular, we multiplied, like we did this last unit. We distributed, right? We did 2x times x, which is what? 2x squared. 2x times 5 is 10x. Okay, good. And we're on page 321 if you're just getting with us. And then we also did binomial times binomial, and those made trinomials. So you're going to see that what we're doing now in this unit is going backwards. We're giving you this and wanting this. Okay? So here's this in terms of binomial. I get my x squared plus 3x plus 1x. 3 plus 1 is 4x. 1 times 3 is 3. So there's my trinomial from those two binomials. Are we okay still? Okay, and I'm going to FOIL out this guy too. 2x times x, 2x squared. Let's make my pen a little bit thinner here. Oh. Okay, 2x times 4 is 8x. 3 times 3x is 3x. 8 plus 3 is 11. 3 times 4 is 12. So there's that one. Also a trinomial. Binomial to trinomial. Okay. All right. A binomial by a binomial that forms a binomial. So this one, who remembers what happens with these? Yeah, when you have a minus 5 and a plus 5, the middle cancels. So what happens is we're left with 2. That's what they're talking about. So I'm going to go x squared, and then see how I get a 5x and a negative 5x. And a negative 25. So those go away because I have a positive 5x and a negative 5x. Okay, any questions yet? Again, so what I want you to focus on is we want, for this unit, we want to take these and go this direction with them. We want to, given this, and I want to get this. That's factored. Given this, I want to get this. That's factored. Okay? So when we're factoring, we're trying to go backwards. Okay? All right. Finish this page here. Okay, so in these examples, we've expanded the product of polynomials to form a sum or a difference of monomials. Let's go down here. Complete the following using the results attained above. So factoring by removing a common factor. So from above, like I told you, we're just going backwards. So what do these have in common? That's what today's is about. They both have a 2 in common, and they both have an x in common. So when I pull out a 2x, when you're pulling something out, what operation are you doing? What mathematical operation are we doing? Division. Good. So we're dividing 2x out. So what's 2 divided by 2? It's 1. So it essentially kind of goes away. It cancels. When I take an x from an x2, what do I have left? An x. Do you see that? Now, as you can check yourself, 2x times x is 2x squared. So you can confirm that you have it correct. Okay, what's 10 divided by 2? 5. And then what's x divided by x? 1, or cancels. It cancels, yes, but not 0. It's 1. Okay, you can check yourself. 2x times 5 is 10x. So I know that I pulled out the correct number. Is that okay? All right. All right. So this one, to factor this guy, just going from the above, it's going to be x plus 1, x plus 3. I'll teach you how to do this. It's not this lesson, so I'm not going to explain how I knew that other than you're just getting it from the top. Okay, and then this one we got 2x plus 3 and x plus 4. And this one we got the x plus 5, the x minus 5. So this is the direction we're wanting to go with this unit. And today we're focusing on this level. Okay. All right, so greatest common factors. In the unit number in the unit on numbers, we met the concept of the greatest common factor of whole numbers. Remember GCF. So the GCF of 48 and 72, we would break down and figure out what that was. And in this case, it would be what? Well, no, their greatest common factor, the biggest number. So remember, they have a 2. So I have this. They have 3 2's in common, right? And then they have 1 3 in common. So that's why they have 3 2's and 1 3. So we multiply that together to get the greatest common factor. So 2 times 2 is 4, times 2 is 8, times 3 is 24. So 24 goes into these 3 numbers, and that's the biggest possible number. Okay, now do you have to do that method every time? No, you're going to get used to the pattern. You're going to get used to recognizing it. Okay? Like let's say, for example, you just tried 2. Well, if you take a 2 out, that'd make a 24 and a 36. They're still 2's, right? So you kind of see there's still more stuff you can do. All right? Any questions yet? All right. Okay, so it says the same process can be used to determine the greatest common factor of 2 monomials, like 6a3 and 9a2b. So 6 and 9 have what in common? A 3. That's right. Good. So that's one of them. They also have, what else in common? A, but how many A's? 2, because the smallest one is an A2. So I can take A2 out. I can take an A2 out. Okay? Now, that's because, see how they wrote it here, all multiplied out. So 2 times 3. 1, 2, 3. 9, 3 times 3. 2 A's and a B. So look, we have a 3 in common and 2 A's. 3 in common and 2 A's. So what is the actual GCF? Well, what's A times A? A squared. So 3A2 is the GCF of those 2 monomials. Remember, monomial is not a fancy word. It just means one term. Okay, we'll go through a couple examples here, and then I'll pause so you guys have a chance to practice. Maybe ask some more questions. So let's get down here, let's do these examples, and then we'll try some practice problems. Okay, so write the prime factorization. Oops, I don't want that. I always forget, bad habit. Okay, write the prime factorization of 8x squared y squared and 20xy cubed, and determine the greatest common factor of 8x2, y2, and 20xy3. So I want you to write them out and do the prime factorization is where you tree it out. You just break it all the way down. So when I break an 8 down, what does 8 break down to in terms of 4 and 2, which the 4 breaks down to 2 and 2, right? So so 8 is 3 2s, right? So I'm doing the 8 right now. Then how many x's do I have? Again, this is just for visualization. This is just for understanding. You don't have to do this every time. How many y's do I have? 2. Okay, so there is my 8x squared y squared. Okay, 20. What does 20 break down to? 5, 2, and 2. Good. And then how many x's? How many y's? 3. Okay. So there's my prime factorization of them. So just so you know what we're talking about, this one is the 8x2 y2. This one's the 20xy cubed. So with that written out, what is our GCF at this point? What is the GCF? They both have at least how many 2's? 2. So what's 2 times 2? So they have a 4 in common. Do we understand that? Okay, so let's go ahead and circle these so you guys know what I'm talking about. 1, 2, 1, 2. That's what they have in common. Okay, all right, hold on here real quick. All right, so the 4's match up. So what do they have in common in terms of x's? 1x, this one and this one. So they have an x in common. And what do they have in terms of y? 2 y's. So we have a y2. So this right here is what we call the GCF. That's the greatest common factor of those two. Okay? Any questions yet? Okay. All right. So the greatest common factor of two simple monomials can be determined by inspection, just by trying to figure out what they have in common by the number. Like 10 and 15, they have a what in common? A 5. P3 and a P2, I always tell my students, what's the smallest P they have? The P2, that's what you can take out. Okay, so if this was a P9 and that was a P1, I can only take out a what? A P1. That's the smallest thing I can take out. So look for the smallest exponent they have in common. Okay, anyway, so let's try a couple of these here. So what does, we'll kind of go around the room here. So Xander, what number does A have in common? What number does 12 and 15 have in common? 3, good. Okay, and then Brandon, what A can I take out? A1, good. Because A1 and A2, the smallest is A1. And what B can I take out, Jose? B1. So 3AB is my GCF. We just did that one. Okay, questions there yet? Perfect. Okay, Mr. Robistan, what does B have in common for number? 6, good. Now, we don't take out a negative because they both don't have a negative, so we don't need to do that. Okay. What is the X I can take out, Taylor? X3, yeah, good. X3. And Josh, what Y? Y2. So 6x3, Y2 is my GCF there. Very nice. Okay, Breezy, I'm going to give you 2 questions. Is there a number I can take out? A 1, which is nothing, right? And then what A can I take out? A1. A1. Okay, good. What B can I take out, Tatum, if any? Do they both have a B? So I can't take a B out. So then what C can I take out, Tatum? C2. Is that good? So my GCF is AC2 there. I couldn't take a B out and I couldn't take a number out because one didn't have a number and one didn't have a B. So AC2 there. Okay, let's see here, Janae. Now it's giving us a group of 3. What number do they have in common in the group of 3? Negative 10. They all have a negative 10 divisible. So we're taking a negative 10 out. Very good. Okay, Mike, what's the A they have you can take out? A2. A2, good. And Chad, what's the smallest B? B1. B1, good job. Okay, very good. So what I want you guys to do right now is I want you to take the next, I'll give you 8 minutes. I want you to do 1 through 3 as your practice here. Okay. All right, so to continue, we've got one more page. It's mostly just examples here. 1 page and a little sliver on the next page. But so it just kind of talks about factoring, like what that means. So I think a couple of key words here. that I would point out is that we want to do, when you're factoring is getting a process which you have a sum or difference expressed as a product. Okay, so this right here is not factored, well, this could be if you couldn't do anything, but see right here, this is factored form because I have a product of two binomials, monomials, or polynomials. Okay, so by factoring them out, we get it in the form that we want in terms of a product. So I think the key word I'm trying to say is product of terms. Okay, that's what we're looking for when we're factoring. So on example 3 here, 21x and 14y, well, x and y are different, so they're not in common. The only thing they have in common is a what? A 7. So that's why 7 times 3 is 21, 7 times 2 is 14. So this right here would be the factored answer. All right. So what did they pull out right here? 5x squared. Very good, Mike. 5x squared. They all have a 5 in common. They all have at least an x2. 2, 3, and 4. So 2 is the smallest. Okay, good. All right, let's move it up here. Okay, in each case, the greatest common factor has been removed to complete the factoring. So they took out a 5a. What would that make this? What's 25a divided by 5a? 5. Good, a 5. Does that make sense? So 25 divided by 5 is 5. A divided by a is cancels. It's gone. You took it out. Okay, how can you check that? You can check that by multiplying. What's 5a times 5? 25a. Okay. All right, Xander, what's going to be right here? What's the missing piece there on B? They took a 2 out. So 16 divided by 2, Xander, was 8. 9p. So 18 divided by 2 is 9. So 9p. P and q are different, so we can't take out a p or a q, so we leave it. Good. Okay, Brandon, what is going to be left over here? Negative 2m was pulled out, so what's left inside? 2n. Yep. Took 6 divided by 2. 3. 3m. So 2n plus 3m is what's left. Very good. Okay, Josie, what's going to be left on D? So what? 2xy squared minus 5y, okay, plus 1. Very good. This right here is really important, Josie, good job. The plus 1, that's important because a lot of people don't put anything there. They think if I pull out, it's gone. Well, there's still has to be something to hold that place because 9x divided by 9x is 1. So you have to make sure you leave a 1 there. People a lot of times like to put a 0. That makes sense? Hopefully, maybe, kind of. Okay, all right, Chris, factor each polynomial by removing the greatest common factor. What's the greatest common factor for A? 2. Okay, good. So 2 comes out. It gives me 10x minus 3. Okay, Taylor, what's the common factor for B? 4x what? Yep, 4x2, which gives you 4x squared plus 1. That's what's left. Okay, Josh, what's the common factor for C? 2a squared. Nope, they got a1s. So just 2a, and then what about B? What's the smallest one? 2. It's 2ab squared. That's going to give you a 5. Okay, 10 divided by 2 is 5. A3 divided by a1, you subtract exponents, so that gives me an a2. B2, it's gone. plus 8 divided by 2 is 4. A came out, it's gone. B3, B2 is a B. The 2 came out, the A came out, B4 and B2 gives me just a B2. So there's your answer there. 5A squared plus 4B plus B squared. Okay, Breezy, you want to try D? 3. Okay, good. And what? 3P. And that leaves me with 4P squared. Negative 6 divided by 3, negative 2P. 15 divided by 3 is 5, and the P was taken out. Whew. Tatum, you ready for the big one? What do you think on E? Let's just do it one thing at a time. What number do they have in common? 5. Okay, what X? X1, X2, and X4. X1, Y2, Y4, Y2. Z3, Z2, and Z5. Z2. Good. All right, let's see what's left of all this mess here. 25 divided by 5 is 5. X came out. Y2 came out. Z3, I took 2 Z's out. I have 1 Z left. 5Z is your first term. 20 divided by 5 is 4. With a negative, the minus stays. X2, I took an X out. I have 1 X left. Y4, I took 2 Y's out. I have 2 Y's in. Z2, I took a Z2 out, so it's gone. Okay, last chunk here. 30 divided by 5 is 6. X4, I took an X out. That's an X3. Y2 is gone. Z5 is now a Z3. Ran out of room there a little bit. It was close. Very good. All right, we just got one more example. Okay, so the surface area, and this is good for your midterm because surface area is on your midterm. The surface area of a cone is given by the formula A equals pi r squared plus pi r s, where r is the radius of the base of the cone and s is the slant height. Determine the surface area of a cone to the nearest 0.01 centimeters, which has a slant height of 7.4 and a base radius of 2.6. So I know this is 2.6. I know this is 7.4. Okay. So I'm plugging this in. So we know the surface area is going to be area equals pi r squared, which is 2.6 squared. Okay. Plus pi times 2.6 times s, which is 7.4. So there's all my formula. Okay. Now, this is going to be, we'll do this here in a second. Plugging that in your calculator, you get A equals 81.68 centimeters squared. It's nearest hundredth, like they asked. Nearest hundredth. Okay, write the formula in factored form. What's that mean? Well, let's look at the formula. What do they have in common? Pi. And a 2.6. That's their GCF. So pi came out here. There's two 2.6s here, so what's left? One 2.6. Do you see that? So there's 2.6, there's two of them. We took one out, so now there's just one left. So 2.6 times 2.6 would give me the square. This chunk got taken out, so all that's left over there is plus 7.4. So there's your factored form. If you put that in your calculator, you'll get the same thing. Okay? So it's 81.68 centimeters squared again. It says, which method's simpler to use? I think they're probably, I don't know if one's easier than the other. I think this one looks easier. Okay. All right, that is it.